So the next topic is bias compensation techniques. Okay, so this is another small topic under biasing. So here we are going to see how we can use other special devices to compensate for variation in the collector current. So we have already designed the biasing circuit and it is going to provide a very good stability for your circuit. In case if that thing is also going to fail at some point of time, what type of arrangements I can do to ensure that the Q point is always at the center of your DC load line. So these things come under bias compensation techniques. So see here, biasing circuits we have already discussed and they will stabilize the Q point. So there is no doubt about that. But in case if even after designing your biasing circuits, if there is a variation in collector current, then your Q point, then the Q point will either move up or the Q point will either move down. Moving up means it will go towards saturation. Moving down means it will go towards cutoff. So the active region operation of BJT cannot be maintained. So I'm going to use additional devices called diodes, thermistors, sensistors for compensating the variation in the collector current. So our main focus is on IC because IC will vary with temperature. If IC is going to vary with temperature, all the parameters of the BJT will change. So which will shift your Q point upwards or downwards. So I'm going to consider voltage divider bias because that is the efficient biasing method I have found out. And in that, I'm going to use all these diodes, thermistors, and sensistors to ensure that even after designing this voltage divided bias, if the collector current is going to vary, these components will take care of that and ensure that the Q point is always at the center of your load line. So that is the main logic behind designing all these bias compensation techniques. The first method is I'm going to use a thermistor. So see here the circuit, it is a voltage divider bias. You have a collector resistance RC, you have emitter resistance RE, you have bypass capacitor CE, you have voltage divider bias R1, R2 across the base emitter junction. See, I am going to have a thermistor parallel to R2 in the base side. So I am going to put the thermistor in the base region parallel to R2. See the location of RT. And the thermistor will have a resistance, it is called as RT. Now what is a thermistor? The thermistor is a device which is going to have a temperature, which is going to have a resistance which varies with temperature. And how it is going to vary? If my temperature is going to increase, the resistance value of thermistor will decrease. So which means it is a negative temperature coefficient device. See here in the last line, I am going to put a thermistor RT parallel to R2, which is going to have a negative temperature coefficient, which means that if my temperature is going to increase, the value of RT will be reducing.